Hello guys, this is my second video regarding the digital principal and computer organization. So in my previous video, I will explain about the what is the syllabus and what are the 5 units and what is the use of studying the digital principal and computer organization. So this subject was given in the Anna University syllabus for third semester paper for CSC, IT, CSBS and AADS department. And this subject code is CS3351. So let me move on to our class. Basics of number system and code. What is you mean by number system? Why we want to use the number system in the digital circuit? So the number system is used to represent the information in the digital system. So we want to study the number system to represent our data and information in the digital circuit. Usually the number system will be classified into 4 types. First one is binary number system and the second one is decimal number system and the octal and hexadecimal number system. What is meant by my binary number system? Binary number system usually carries two values. One is 0 and another one is 1. So this is called as binary number in computer. So for example, if we get the signal pulse like this means if it is in the low value, it is denoted as 0, and if it is in high value means it is denoted as 1. That is mentioned in this line. The absence of electronic pulse is represented as 0, and if the presence of electronic pulse is represented as 1. So each digit is known as bit. For example, here we will have totally 6 digit, right? So each digit is known as 1 bit. So totally here we will have 6 bit. 4 bit is known as the nibble and 8 bit is known as the byte. The base value of binary number system is 2. So every number system has different base value. The binary number system base value is 2. Here are some of the example of binary number. So 101001 is one of the example of binary number, and it is enclosed with the 2. Next one is decimal number system. Like binary number system, it also has different base value, that is 10. So that is 10. Usually its digits start from 0 to 9. So there are totally 0 to 9. And its base value is 10. Usually it contains 10 digits and 0 is the value and 9 is the maximum value. This is the one of the example of decimal number 2541. I am expanding this 2541 with this place value. So 1 place value is 1 and 4 place value is 10 and 5 place value is 500 and 2 place value is 1000, and 1000 is written as 10 to the power of 3 and 100 is written as 10 to the power of 2, 10 is written as 10 to the power of 1, and 1 is written as 10 to the power of 0. That is anything power 0 is equal to 1. Finally, we will get the same value as 2541. Next type is octal number system. So octal number system. Octal number system has a base value of 8. So usually it contains the values from 0 to 7. Decimal number system contains value is from 0 to 9, but octal number contain the value is 0 to 7. So 0 to 7. And 0 is the minimum value and 7 is the maximum value. So usually the octal numbers will be represented in 3-bit value. So the 0 is equal to the octal number of 000 and 1 is equal to the octal number of 001 and 2 is equal to the number of 010. Will be denoted from first column is it will be filled with the help of shortcut. First column is filled with 4041 and the next column is filled with 2021, again 2021, and the final column is filled with 010101. These are all the examples of uh, octal number. It is enclosed with the base 8. So next one is, and the final type is hexadecimal number. The hexadecimal number has 4-bit value. 4-bit value. It has values from 0 to 15. 0 to 15. And here 0 is the minimum value and 15 is the maximum value. From 0 to 9 it is represented as numerical number, but from 10 to 15 it will be represented in alphanumeric value. That is, from 10 is equal to A and 11 is equal to B and 12 is equal to C and 15 is equal to F. So usually the hexadecimal number was denoted with the alphanumerical form, that is FAC2 and base 16, and its base value is 16. Next topic is number base conversion. Usually we can able to convert the number from one type to another type, right? Like binary to decimal, binary to octal, and binary to hexadecimal. Likewise, the decimal number is also converted into binary, octal, and the hexadecimal. So the octal number can be converted into in some other 3 types, and the hexadecimal number also converted into remaining 3 types. So for in this video, I will explain about only binary to other number conversion. First one is binary to decimal number conversion. This is a binary number. I need to convert this number into decimal form. So binary number base value is, and the decimal number base value is 10. Okay. So 101, right? So I need to give the position to each value. So this position is represented as 0 and this is 1 and this is 2. This is the position of 2 to the power value. So the 1 is written as 1 into 2 to the power of 0 because it is 1 in the position of 0 plus 0 into 2 to the power of 1 and plus 1 into 2 to the power of 0. Finally, you need to simplify this and you will get an answer of 5. So this is the decimal value of 101. And the next conversion is binary to octal number. So binary to octal number. Here you will convert the binary number into octal number by splitting the given number into 3 digits. That is from right hand side to left hand side. Afterwards, you need to directly write this. 1 is represented as 7. I will already show you in the octal number tabular column. And 110 is represented as 6. Afterwards, 101 is represented as 5. So this is a conversion of binary to octal number. First of all, you need to split that given binary number into 3 digits. Afterwards, you need to write directly the decimal number as for the splitted 3-digit binary number, and it is enclosed with the base value of 8 because octal number base value is 8. Next one is binary to hexadecimal. It is similar to binary to octal conversion. Octal we will split into 3 bit, but here you need to split that given binary number into 4 bit. Here see, so this is the total 11-digit number. You need to split the given number from right hand side to left hand side. So first 4 digit, remaining 4 digit, and finally you will get an 3-digit number, right? For this you need to add 0 in front of the number to get 4-digit value. Afterwards you need to directly write the decimal value of this 4-bit value. Okay. So 0111 is equal to 7 and 1010 is equal to A. That is the decimal value number is 10. Okay. And 1011 is equal to 11, that is represented as 11 B. So hexadecimal number is usually in the alphanumerical form and it is enclosed with the bit of 16. So this base value is 16. And the next one is the gray code. What is meant by gray code? Gray code is used to eliminate the error of digital circuit. So if any transition from two values between 0 or 1 or 1 or 0 means there is a chances to occur error. So in that case, we will use the gray code to eliminate the error. Here I will explain you the steps to generate the gray code. So gray code is generated by using the power of n value. If the n is equal to 1 means you can able to get two values. If n is equal to 2 means you can be able to get two values. The n equal to 1 is the number of bit. Okay. The n value is the number of bit. First I will with the n equal to 1. So n equal to 1 means I will generate two values. One is 0 and 1. Okay. Afterwards, I will reverse that given value as 1 and 0. So our final step is to add 0 to the already generated code and add 1 to the newly generated code. That's what I am mentioned here. So I will explain with this picture. N equal to 1 means we can able to generate only two value. One is 0 and another one is 1. One is 0, another one is 1. With this help of these values, we can able to generate the values for n equal to 2. So you can take this value as base value. Afterwards, you need to reverse these values. That is, you will take this value 0 and 1. You need to reverse means the value is 1 and 0, right? So this is the original code and this one is the newly created code. For original code, you need to add 0 before that. So that is this. And for newly created code, you need to add 1 to the previous of the code. So this is the four values for when n equal to 1. Sorry, when n equal to 2. And you need to consider this value to create the value for n equal to 3. So this 4 value is base value to generate a code for when n equal to 3 bit. So first of all, write it down this four values as it is. Afterwards, you need to reverse this number. Take this last column and you will reverse. That is 0, 1, 1, 0. And take this column and you need to reverse this column 1, 1, 0, 0. Then this is the already generated code and this is the remaining, this is the newly generated code by reversing this digit. So for original code you need to add 0 in the previous. For newly generated code you need to add 1 in the previous of every digit. So this is the method to find the gray code for when n equal to 1 or n equal to 2 and n equal to 3. When n equal to 4 you need to find the value means you need to consider this value as the base value to generate the code for n equal to 4-bit value. So here I will make binary code equal to 1 means we will have only two codes. When n equal to 2 means we will have these four values 0 0 0 1 1 0 1 1. So with the procedure, we will get the gray code like this. Afterwards, n equal to 3 means the binary value is like this and the gray code is generated with the procedure. So this is the tabular column I will mention about from 0 to 7 decimal value is equal to binary value and the gray code value. XS3 code is one of the special type of code used in the digital system. So used in the digital system. How will you convert this XS3 code from binary number to decimal number? These are the steps I will mention here. First of all, you need to find the decimal number for given binary number. So you need to find decimal number for given binary number. Then you need to add 3 to each digit of that decimal number. Decimal number. And you will find the binary code for each digit separately. So let me take this example. Let me take an example of 101. Already I will mention this 101 decimal value is 5 in the previous slide. So with this 5 you need to add 3. This is the second step to find out the XS3 code. Finally, you will get a value of 8, right? You need to find out the 4-bit value for this 8. That is, so that is 8 is represented as 1000. So 1 1000. So this is the XS3 code for this 101 binary code. And there will be one more shortcut to find out the XS3 code. You can directly add 0011 with this binary number to find out the XS code. This is the decimal number of 0 to 9, and this is the BCD code of every decimal number, and this BCD code is added with 0011. So for this 4-digit number, so I will take this number, right? 0 0 0 0. So 0 0 0 0 0 1 1. You need to add this. So this is the step to find the XS3 code. This is shortcut method, one of the shortcut method. 1 1 0 and 0. Okay. So finally we will get the XS3 code for 0 value. Likewise, we will find the basic gates used in the digital circuit. First one is AND gate, OR gate, and NOT gate. These are all considered to be a fundamental gate to construct a digital circuit. And two universal gate. There are two universal gates to design a circuit. One is NAND gate and NOR gate. It will be used in the Boolean function of sum of product and product of sum. So, it will be used in Boolean function. First one is AND gate. What is the use of AND gate? What function is going to perform? It is going to perform the multiplication operation. AND gate has 2 or more input and it produces one output. So, the logical symbol of AND gate. So, finally we will get an output of A dot B. You need to multiply the given input, then you will find the output, that is 0 into 0 is 0, 0 into 1 is 0, 1 into 1 is 0, and 1 into 1 is 1. Next gate is OR gate. It will perform the addition operation. So, will perform the addition operation. Like AND gate, it has 2 or more input and produces an single output. So, this is the logical symbol of OR gate. Its operation is addition. So, 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1 and 1 plus 1 is, we will get 10, but you need to take the value of this value as 1. Okay, and NOT gate. What is the use of NOT gate? It has only one input and produces an one output. So if we give an 0 as input means it will produce as 1 as output. If we give 1 as input means it will produce as a 0 as output. So this gate is also called as logical inverter. So the output of the NOT gate is called as logical inversion of input. It has one input and one output. Next one is universal gate. Universal gate has two gates. One is NAND and another one is NOR gate. So this gate is used to construct any circuit very easily. So if you want to sum of product means you need to use AND gate. Sum of product means you need to use their NAND gate. Sum of product. Okay. So NAND gate is a combination of AND gate and NOT gate. So NAND gate is the combination of AND plus NOT gate. Here I will mention the logic symbol. This is the AND gate symbol and this is the NOT gate symbol. So finally the logical symbol of NOT gate is, it is bubbled with AND gate. So it has 2 or more input and produces a single output. So it is an inversion of logical AND gate. So A and B is given as input and the output is represented by A into B the whole bar. That is 0 into 0 is 0, but you need to invert to find the output of NAND gate. That is 1. 0 into 1 is 0 and you need to give the inversion for 0 is 1. 1 into 0 is 0 and you will get an answer as 1. 1 into 1 is 1. 1 is inverted means you will get an answer of 0. So like NAND gate, the NOR gate is used to find the product of sum in Boolean function. Product of sum in Boolean function. So it is a combination of OR gate and NOT gate. So the logical symbol of the NOR gate is bubbled with OR gate. And this is the output of the NOR gate. A plus B the whole bar. So the truth table is inverted to the OR gate. It is also called as inversion of logical OR operator. So 0 plus 0 is 1, right? But 0 plus 0 is 0. You need to invert that output to find the input. So 0 bar is equal to 1. And 1 bar is equal to 0. Okay? And other than universal gate and basic gate, there will be two gates in the digital circuit to construct an off adder, full adder, comparator, and so on. So XOR gate is also known as exclusive OR gate. This is the logical symbol of XOR gate. It has two or more input to produce a single output. The exclusive OR gate gives an output only if it has dissimilar values. It means if it has its input as two different values means its output will be 1. If it has similar input value means the output will be 0. This is a shortcut method to find out the truth table for XOR gate. So 0 0 is the same input, you will find an output as 0. So 1 1 is also same input, means you will find an output as 0. So this two as different input, so you will get an output as 1. So if you get 1 as output, means that is high value, and 0 as output, means that is low value. So the exclusive A, exclusive B, sorry, exclusive B, okay. So it is explained with the formula is A bar dot B bar B plus A dot B bar. Okay, you need to substitute these two values here, means you will get a value of 0. Like that you need to substitute A value and B value in this formula, means you XNOR gate is also, it is a special type of gate and is known as a exclusive NOR gate. This gate is opposite to the XOR gate and it is used in constructing the off adder, full adder, the off subtractor and the full subtractor. The exclusive NOR gate is also abbreviated as XNOR gate and XNOR gate. It is a logical symbol for XNOR gate. So output will be mentioned as A exclusive B E whole bar. So this is the output of the exclusive NOR gate. So this equation is expanded like this: A bar B bar plus AB. So it is opposite to XOR gate. So if we have similar input, means we will get a value of high value, that is 1. If we have different input, means we will get an output as 0, that is low value. See here, these two row as similar input, so we will get an value as 1 1 as output. These two in row as different input, so we will get an value as 0 as output. So just I will take these two values and substitute this in this formula to get an output like this. So A bar, right? Now I need to substitute A equal to 0 and B equal to 0. So A equal to 0 means it here I need to substitute the value for A bar. So 0 means here I need to substitute 1. And B bar means I need to substitute here 1 plus, and keep the values for A, B as it is, that is 0 dot 0. Okay. So 1 into 1 is 1, 0 into 0 is 0. So 1 plus 0 is, finally you will get a value of 1. So likewise you will substitute this all values in this equation, means you will get this as an output. Yeah? So in this video I will explain about what is meant by number system, what is the purpose of using the number system in digital circuit, and what are the basic gates, universal gate, XOR gate and XNOR gate. In next video I will explain about what is meant by combinational logic, what are the combinational circuit, and what is the use of K-map, and how the K-map is used to reduce our equation like that. So